Two vectors are opposite if they have the opposite. Sorry, two vectors are opposite. If they have the same magnitude in opposite direction. And I apologize again, today's was a lot of terminology. All you're thinking basically enough. If the first vector is going 5 kilometers west, the opposite is 5 kilometers east. Right? It's like if you add, you go going like this, to find the opposite, you get back to the starting point. That's all we're saying for opposite vectors. We're going to do a lot of proofs in this unit. This is like identity proofs and all that stuff again, right? Where you're going to need to know, but you're going to, this is the whole course of proofs. The whole entire, until you're done taking calculus is all proofs. That's yay, nobody cheered. Okay, that's all right. That's okay. But the idea is we're going to go through this right now. Here we go. So, example 2, we're up to? Example 2, let's go. Here's parallelogram AB, say in parallelogram ABCD. It's very fast here. So there's parallelogram CD. Remember for parallelograms, in any parallelogram, AB and CD are going to be the same length, and they're going to have the same slope. I'm going to give you a second to scribble that down. I'll take a drink of coffee, and then I'll ask you to give me one set of things that are equivalent. So what things are equivalent here?
Oh, would it be A, B, and
Thank you. AB is certainly equivalent to DC, so we can call them equal. What else is equivalent? There are a few more.
Wait, this is just a question. If you said A was equivalent to CD, would that
No, certainly not.
be wrong?
AB is actually opposite.
No, but like if you change the order of the letters.
Yes, it makes a huge difference.
Okay.
AB means you're going from A to B.
Okay.
C to D means you're going like this. So these would be ones that have the same magnitude, but the opposite direction. They're going the opposite ways. Okay, that's the one thing I wanted you to say there, so I'm glad to mention that.
Yeah, DA
Yeah.
is equivalent to CD.
Good. DA is equivalent to CD. Any other equivalent vectors? There are, in fact, 2 more. Change order. So BA. And AD. Okay with that? The logic there? They actually pointed in the same direction. So again, what Sarah was asking was an excellent question, right? So I'm going to do the opposites then. AB is opposite CD. BA is opposite DC. There's one other thing I should probably mention here for this. This is sort of getting to what I was mentioning before. If two things are opposite, as far as math-wise, what does that mean then, as far as math goes?
It's direct 180.
Good. Let's look at numbers though. What's the opposite of 3? Negative 3. So what we're going to say is that AB is technically equal to negative CD. Right? Because it's going to be in the opposite direction. That's what I'm saying for that. Okay? BA then would equal negative DC. Right? So it's negative DCD would mean the opposite, negative would be the opposite. I'll finish something. BC equal to negative, It's dA? Negative dA. Doesn't mean to say that. CB. Sorry, this is all just notation stuff today. CB is negative AB. Any questions, please be brave. John stretching, just welcome back to physics, hopefully. If you're doing physics, don't worry, it's just going to be new terminology. Okay. Rob, all good? Rob, as well? So fine. Y'all have been pretty nice. Okay, so time for a joke here before we move on. Purposely make in this class, yeah. It'd be great. I'd be writing on the board and they'd be erasing it as soon as I did. Okay. Here we go. Example 2. Example 3 says. So I know this is dry. We gotta get through this today. Is each a vector or a scalar? If it is a vector, state the opposite. I'm going to write 8 of these on the board, and you guys are going to take a second and do. Ready with that left word? And what's this scribbling? These are the left word? Okay. I'm going to write these 8 of them. I'm going to give you a few minutes to take a break and try and do these. Vector, scalar, I want to know, and the opposite. A says a ball rolling along the floor at 2.5 meters per second. We're going to say John is pushing a weight uh, 250 newtons to the west. Sound has an intensity of 50 decibels. Okay, you can change it however you want. The train travels northwest. At 115 kilometers per hour. Melody travels 700 meters at a bearing of 120 degrees. A box has weight 84 newtons. The high temperature yesterday was -3. And Robbie travels 120 kilometers per hour. So it's 25 degrees west. Alright, the reason I'm making a big deal about this is not that you guys can't figure out easily what's a scalar and what's a vector. The problem is what happens in this course is that you guys will give me a vector answer as a scalar. Right, so you'll just say that Robbie moves 120 kilometers per hour, okay, which isn't a vector, not to give that one away, okay, right, but, so what I want you to do here is just do the opposite. If something is a vector, make it the opposite vector. If it's a scalar, just say scalar, and hit stop on the video.